Alright, let's start the incomplete dominance practice screencast. Remember, incomplete dominance is the inheritance pattern in which we see a blended intermediate phenotype when we see a heterozygous individual. Alright, let's get right to it. For these, we need to read the problem carefully because it's usually going to tell us the inheritance pattern in the problem. So in this case, in chicken feather color, the black allele is incompletely dominant over the white allele. The intermediate phenotype is called erminette. Show the cross between a white rooster and a black hen. First things first, let's figure out what alleles or what symbols we want to use for these different alleles. We have a black feather color. Let's use big B for that symbol. And we have a white feather color. I want to use the same letter because it's the same characteristic, so I'm still going to use a B. I don't want to use a lowercase b because that would imply that white is recessive to black. So I still want to use a big B, but I want to somehow show that they're different. So I'll just put a little tick mark there. Oops. So now I have big B for black and big B prime for white. Alright, let's show the cross. First I need to determine my parental genotypes. The white rooster will have this genotype. The black hen will have this genotype. If I cross these, we will have all offspring showing the exact same genotype and of course having the exact same phenotype. So if I were to do my genotypic ratio, I could just say they are all B prime. My phenotypic ratio, they are all that erminette color. All right, that's the blended intermediate phenotype. Next problem says show the F2 generation from the previous problem and show the genotypic and phenotypic ratios. So if we take one offspring with that genotype and cross it with another offspring of this genotype, we will get this result. Alright, genotypic ratio. I see a 1 to 2 to 1 ratio. By that I mean I see 1 BB, I see 2 BB prime, and I see 1 B prime B prime. The phenotypic ratio, I see 1 black rooster, or I'm see 1 black offspring, I see 2 erminette offspring, and I see 1 white offspring. So in this case, for intermediate or for incomplete dominance problems, typically the genotypic ratio and the phenotypic ratio is the same because the intermediate genotype has its very own phenotype. Next problem. Is it possible for a black chicken to have an erminette or white parent? For this problem, I sort of need to work backwards. So what I want to do first is write the genotype of this black chicken and then show it in a Punnett square. And now I want to kind of play around with the potential parents. The only thing I know for absolute certain is that this offspring's parents had to have had 1 black allele apiece, and I'm really not sure what else they could have had there. Okay, but the only way that that offspring could have been produced is if both parents had at least one allele that was black. All right, is it possible for either of these parents to be white? No, because the white genotype is B prime B prime, and that's not possible with the Punnett square that I have shown. What is the erminette genotype? That is B prime. These individuals that I show in my genotype could be B prime. So it is possible for a black chicken to have an erminette parent. It is not possible for a black chicken to have a white parent. Next, what are the chances of a white rooster and an erminette hen producing an erminette chick? All right, let's find out the parental genotypes. The white rooster and the erminette hen. let's show that cross. Okay, what are the chances that they have an erminet chick? I see half of these individuals as being white, and I see half of these individuals as being erminet. That means they have a 1/2 or 50% chance of having an erminet chick.